optimization problems are by far and away one of the most important applications of calculus. And they're important because they have to do with efficiency of systems. So what I'll be able to do is find maximum values for a system or minimum values for a system. And they are best explained by giving a particular example. And this is a very classic optimization problem in calculus. A farmer has 2,400 feet of fence and wants to fence off a rectangular area bordering a river. What are the dimensions needed to fence off the largest possible area, assuming the river did not need to be fenced? So here I have a few possibilities of how one could set this up. And what this is designed to show is the large disparity between efficiencies of systems. Here, this left area is almost half of what this right area is. And this center area is more than 3 times the area of the left and nearly double that of the right. So clearly there are a lot of potential benefits to doing things correctly and the most efficiently the first time. If someone were to set up something like on the left, it would be 3 times as expensive as the person doing what is in the center, and the center is not even the most efficient way of setting this up. So how can I use calculus to find the most efficient system? Well, first thing I'm going to do is draw this and then attempt to set up a maximum and minimum value problem where I'm looking for the maximum height of a curve given a particular set of numbers, or the minimum. Sometimes I'm looking for the ability to cut costs rather than trying to maximize space. It just depends on the problem. That's why these are so important, because they're so versatile. So I've got my rectangular area. And I don't need to fence off the river. So these two sides are going to be the same length, since it's a rectangle, and then this will be a separate length. So what I've got with so far is I have the perimeter 2,400 feet. So I have 2,400 feet of fence to work with. So the perimeter in this case is going to be equal to 2x plus y, and the perimeter is equal to 2,400. And what I'm looking for is the area. So the area of this is going to be x times y. So what I'm going to look to do is set up an optimization problem for the area. What I mean is I'm going to get an equation for the area, and then I'm going to try to find its maximum value for the curve. And actually I'm going to be looking for x values. So I'm going to be looking for values greater than or equal to 0, and greater than or equal to 1200. In this case, these values are not so important because I'm going to be dealing with a linear function and then a parabola. And a parabola can only have one maximum or minimum. But say I had a x to the 5th or something like that. A curve like that can have multiple maximums and minimums, and in this case I can't really have an x value that's greater than 1200 because these two sides have to be at least equal length, and 1200, that would mean I would have absolutely 0 y value, so even that's not really possible. But this might save me some time. Say I've got a curve and it has a 0 or a maximum minimum value at, say, 3,000. I don't need to look at that one because it's not within my range that I'm going to be looking for. But anyways, that's just kind of an aside. So I have the perimeter and I have the area. So what I'm going to need to do is try to set up, for at least this particular problem, they'll all be different depending on what information I have. But for this one, it's a very easy one. I'm going to set up this part perimeter to 2,400 is equal to 2x plus y. I can isolate the y. So this equation tells me that the perimeter, or y, must equal whatever the x length is minus 2,400 times 2. Because I've got two x sides, and I've got 2,400 to work with, and however long x is, I'm going to have to multiply that 2 and subtract it from 2,400, and that is whatever y is. So now that I've got y by itself, I'm going to put it into this area formula. So area is going to be equal to x times 2,400 minus 2x. And I'm just going to multiply this out. Now this formula gives me the area with a perimeter of 2,400 and minus 2x. This gives me the area depending on how big the x is. So if I have x of 1, then it will give me the area for that, because it will this term factors in the y. So it's going to give me the total area of whatever my x is. But I'm not looking for any x. What I'm looking for is the most efficient system. I'm looking for the maximum area that I can have. So if I were to graph this, I would get a graph, and what I'm looking for is the highest y value of that graph. Y is area in this case. So what I'm going to do is try to find the maximum of this curve, and how I do that is I take the derivative, find where the derivative is equal to 0, and then I find out if there's more than one maximum or minimum value. In this case it's going to be a parabola, so there's only going to be one maximum or minimum value. So this is a very easy one. Then I take that, and then that is my maximum for the curve. So what I'm going to do is take the derivative. So this will become 2,400 minus 4x. And now I just solve for this, and x is going to be equal to 600. So this side, for the most efficient system, is going to be 600. And if I want to find the y value, then I go back to my original equation. 2,400 is equal to 2 times now 600 plus y. So then I solve for this, and y is going to be equal to 1,200. And if I wanted to know the area of this, now I just take 1,200 times 1,200. And then that would give me a total area, but that's not what this was asking for. This was just asking for the dimensions. So the dimensions will be 600 by 1,200. That's how to do an optimization problem. Each optimization problem is going to be unique. It's going to be looking for unique information every single time. It could be how to cut costs, it could be anything really. So, but the key idea for applying calculus to this is to get an equation that tells me what that value is, whether it be cost or area or anything else, and then to use the derivative to find out where that's equal to 0, and that will tell me the maximum or minimum value, and then I can use that information to find out whatever it is I'm looking for.